So welcome to the Enabling Water Smart Communities Autumn webinar series. My name is Katie Lawrence. I'm from Anglian Water, and I'm the Programme Manager on Enabling Water Smart Communities. I've just seen a comment in the chat there. Holly just sees a screen that's just black. Is that the same for everybody, or is that just Holly?
It's okay for me.
Okay.
Yeah,
Okay, I'm going to carry on then, and then Nathan, if you can maybe contact Holly in the background, I'll carry on. Okay, so yeah, as I was saying, I'm Katie Lawrence from Anglian Water, the Programme Manager on Enabling Water Smart Communities, and this is the first of 5, potentially 6 webinars in the series for this autumn. And the aim is to share specific progress, updates and outputs from our Enabling Action projects. And today we're going to be focusing on water efficiency and reuse in housing, and specifically the design guide that's been developed in conjunction with Good Homes Alliance and Pollard Thomas Edwards Architects. So, running order for today, or for the session, we'll just give a bit of an intro to Enabling Water Smart Communities, or maybe a bit of a reminder for some of you that have heard of us before and what we're all about. Then we'll introduce the guidance, the design guide that we've developed, and then we'll go into a bit more detail exploring specific areas of the design guide, and then we'll move on to a Q&A section for around 20, hopefully 25 minutes. We've got quite a few questions that have come through prior, which is great. And then if there's any additional that you think of as we go along, then please do use the Q&A function in Teams, and we'll try and pick those up as well. Just some general housekeeping then before we get started. This session is recorded, and that's so we can share beyond today's sessions. But if you do have any objections, please do let us know, and feel free to keep your cameras off if that makes you feel a bit more comfortable knowing that you're being recorded. Any technical issues, then please do put your hand up, put a message in the chat like Holly just has, and hopefully Nathan can help you out with that. And as I said, any questions that you think of as we go, put them in the Q&A function, and we'll pick up later at the end section of the Q&As. So we welcome today Richard Broad from Good Homes Alliance, Dr. Tom Dollard from Pollard Thomas Edwards, and Andrew Tucker from Thames Water. And they'll be either presenting to you today or as part of our panel later. So thanks for joining us, guys, and welcome to the session. So in terms of enabling water smart communities, this is an Ofwat innovation funded project or program exploring the relationship between integrated water management, community engagement and practice, and housing development. And the key aim for this program is identifying the barriers to integrated water management across the UK and looking at how we can unblock those barriers, enabling the delivery of water smart communities. So as you'll see from this slide, we've got quite a few delivery partners from a number of different water companies, academic institutes, and a number of individual organisations from Public First, WSP, Waterwise, and as I've mentioned, Good Homes Alliance and Pollard Thomas Edwards. We also have an independent programme board, and we meet up with the programme board on a quarterly basis, and they kind of help feed back items from industry to help kind of guide our programme and the projects that we deliver within the programme. So before we go any further, just a quick kind of note on what a water smart community is. So for us, this is where water-related assets and systems are thought about and integrated at design stage, and they kind of become the heart of a place and fundamental to its operations. It's also about bringing community members along the journey with us at an early stage so that we can help them understand and create value of water and water assets and the systems that feed their communities. So just very quickly on what's the need and why we're delivering enabling water smart communities. So as I'm sure you're all aware, there are a number of different challenges faced by both water companies and the house building sectors. With water scarcity, we are facing a 4.8 billion litre per day deficit by 2050. And as you know, with climate change increasing, we're seeing more and more extreme weather events from severe droughts right through to flooding at opposite ends of the scale. So 1 in 4 homes will be at risk of flooding by 2050. In addition to that, we have the need, a massive need for new homes, and obviously the government are pushing for 1.5 million homes or new homes to be delivered in the next 5 years. So Angling Water, Enabling Water Smart Communities is looking at how we can address these issues in a holistic manner and in an integrated way, working across sectors to enable sustainable growth. So how are we doing that? Obviously, it's very complex, but at a very high level, we looked at what the challenges and barriers are in our discovery phase, and we developed a framework. This identified 52 enabling actions that need carrying out, and we kind of put them into categories and various kind of focus areas. They include values, assets, and stewardship. And within those categories, we created our enabling action projects, some of which that you can see on the screen now. And as I mentioned earlier today, we're going to focus on water efficiency and reuse in housing and the design guide that we've developed. So without further ado, I will hand over to Richard, I believe, to introduce the design guide.
Excellent. Thank you, Katie. Yeah, and thank you for the invite today. Pleasure to be taking part in this webinar. So I'll just give a very quick introduction to the guide and to the Good Homes Alliance. Jump to the next slide. Thank you. So the GHA, we've been going for nearly 20 years. So we're a non-profit community interest company. We have nearly 100 members from across the sector, and we're really a home for those organizations who want to go further and faster on standards and go beyond business as usual and really deliver best practice. So we collaborate with industry, academia, government. We create lots of best practice guidance like the guide we're talking about today. We curate events, conferences, campaigns. We partner on research, and we're really a networking forum. So our membership includes architects. Perhaps if you jump to the next slide, you'll see the logo soup of all of our members. So I'm sure you'll recognize some of the organizations that there. So a real spread of expertise from across the sector. Thank you. So I think we've covered this off already, but yeah, so we know why the guide's needed. Water stress is a huge problem for both housing delivery, growth, etc. There's lots of reports sort of outlining these problems, but until now, there hasn't been a huge amount of clear practical guidance available. So this is the guide. I won't talk about it in too much detail I don't want to steal Tom's thunder, but it's for architects, it's for planners, developers, housing associations, all those people who want to deliver best practice. So there's some really informative case studies, there's model specifications, and lots of expert insight from the project team that I'll mention in a moment, and a really excellent steering group that we were delighted to have supporting the guide. So this is the project team. A huge thank you to Tom Dollard and Rory Olcato from Pollard Thomas Edwards, who led on the authoring, and they were ably supported by the team at Pollard Thomas Edwards on the design and fantastic illustrations in the guide. A huge thanks to Saffron from Thames Water, who I believe's recently moved on, but she's done a great job on the case studies. And then thank you to Kath Hassel for her work supporting the model spec. And this is the steering group I mentioned, so a real who's who of experts from across the sector. Many of these are GHA members, so we really couldn't have done the guide without their expertise and peer review and feedback, etc. So a huge thank you to our steering group. And of course, thank you to our funders, one of which was Enabling Water Smart Communities and also the UK Water Efficiency Collaborative Fund. which is administered by Waterwise. Just like to flag this up, I'm sure many of you have already seen it this week, hot off the press. So this is the long-awaited consultation from DEFRA on water efficiency standards in the building regulations. So amongst a range of things, they're looking at revising the minimum water efficiency standards, something we'll perhaps pick up on in the Q&A. So we think our guide has really arrived at an opportune moment to allow developers to sort of get ahead of the curve of anticipated tighter regulations. And just to note that the GHA will be responding to the consultation, and we'll share a draft of this with our members and wider industry to get your feedback, as I'm sure many other people on this call will be responding to. So we really encourage you to submit a response by mid-December. Thank you. And just a flag, so this is the second in a series of our Designing for a Changing Climate series. So our first one published 2 years ago was on shading for housing, quite a similar format, very practical, lots of case studies and product solutions. So please do check out that if you haven't already. And then in the past, we've done a number of guides on overheating in new and existing homes. We're actually looking to update those tools. So if you're interested in perhaps supporting that, please do get in touch. We've also done a very simple embodied carbon tool for low-rise residential development. So these are all available on our knowledge base. So that's the link there. I'll put it in the chat in a moment. So please check those out. And finally, I must do a quick pitch to join the GHA. So please consider joining our community of forward-thinking, progressive organizations. It's an opportunity to show sector leadership, show that you're going beyond business as usual and delivering best practice. And we're a really collaborative organization, so there's lots of opportunity to share and learn from your peers. You can get access to and help shape the next guidance document, the latest research, and inform policy. And these are some examples of the work streams we have ongoing on healthy homes, building performance, planning and placemaking, climate resilience, net zero finance, and lots more. And we have networks for local authorities, developers, and social landlords. So there's a lot going on. Please do get involved. There's the link to find out more. And yeah, please just drop me an email. I'll put my email in the chat if you've got any questions. And there's the link to download the guide if you haven't already. And I'll hand over to Tom.
Thanks, Richard. Wow, what a sales pitch for GHA. Amazing. Who wouldn't want to join? Just whilst we're here, you can scan that to download the guide. Obviously, you can go onto the Good Homes Alliance website, whatever way, but it's probably worth doing now if you have your phone. You can then follow through with me as I give you a guided tour of the guides. Yeah, there we go. There's the link. So I'm going to share my screen now. There we go, and put that on that. Should be coming through. Right, so where do we start? I think, yeah, keys in the title, water efficiency and reuse in housing, and it is, as Richard said, part of our Good Homes Alliance series of design guides. So for changing climate, so climate resilience being the key theme. I'm going to skip through most of the introduction because I think Richard's already mentioned that, and I think he's also started talking about why it's needed. And I think, to be honest, most of us on the call understand the main issue around why and what the issue is around water scarcity. I think this one is, in the introduction, is a good one to pause on though. This hierarchy, the diagram, it's adapted from Waterwise. I'm sure many of you have seen this, the water hierarchy, water neutrality hierarchy. We essentially, early on writing the guide, realized that this was key to the framework and key to the solution. And it starts with step 1, water reduction, step 2, reuse water, and then step 3, offset. And we found there were various versions of this, and some local authorities referring to, some not. So we wanted to clear it up and really explain it in a relatively simple way. As you go along, you can see the guide. We've got lots of links to the primary research that sits behind the guide. Yeah, do click on it if you want to see, for example, EWSC's guide here on the case for water smart housing. There's quite a lot of other stuff around costs, all the kind of nitty issues that we've had to deal with. I was really interested to see in the latest consultation that came out yesterday that government have referred to this piece of research around the cost of blocked housing schemes, and we think that's so important that this is really a barrier to development. It's not just an environmental question; it's a barrier to social and economic development. I think again, relatively high level on this one, but maybe we'll have time to discuss this. We quite quickly realized that we need a fittings-based approach rather than going to using the water calculator, which is referred to in Part G. The crux of it is really that real-world usage quite often outpaces, or it's a lot more excess. It's more than those design calculations in the water calculator. So by focusing on the kit and the mechanisms and the requirement for a smart meter, we're really driving forward change rather than driving a theoretical calculation. We've highlighted the link between carbon and hot water and actually cold water as well. That's pretty clear. And then the guide in one is split into three. It's really design guidance. So that's in the first section. There's some case studies, which I'm going to talk to in a bit more detail, and some stakeholder stories that my co-author Rory has put together. I'm not going to touch on the stakeholder stories so much. They're there really to look at some insights into behavioural change and cultural shifts, and more forward-thinking, future-thinking. Who's it for? Well, I think it's quite clear. It's architects. It's really Good Homes Alliance members. So again, it's multi-disciplinary, but with a focus on the clients, so housing associations, local authorities, and planners who are going to be looking at this and setting these standards. Quite early on, we decided to take retrofit out of this guidance. The main reason is it's quite a different process. It's obviously related. Obviously, when we talk about offsetting, nearly always that's going to be through retrofitting. But it does require a different set of metrics, and it's a different process. So we have taken retrofit out of this guidance. It may, I think, in all honesty, it probably needs a separate guide on how to retrofit for water neutrality or reduce water in homes. And the final bit on the introduction, yes, it's part of this series on climate resilience. So I'm going to skip over some of the policy and the national targets. I do want to come back to that in the Q&A. We've obviously got the very recent government consultation that's been published. I'm also going to skip over most of this because I think most people know this. This is the breakdown of typical water use in a home. This actually, when we were researching this jumped out, and it's quite an historic data, but it's the obvious point is that a large proportion of water usage can be replaced by rainwater. So it's obviously a significant way to reduce water. We did some stakeholder interviews and actually built on a lot of really good research from Manchester and Public First and others that, on the perception of water reuse and some of the other blind spots and barriers. So we've highlighted them there. They're not really surprising. Lack of awareness, weak regulation, there's no incentive. The environmental apathy is quite interesting, a cultural one, but essentially water is not seen as an issue. We're in a rainy country, so to speak, and it's not seen as a problem. Albeit that I think that is changing with various temporary bans across the country this summer and drought conditions. So it's possibly is changing, but I still think there is an apathy. Cost is obviously a big barrier for developers and all scales. So we've certainly looked at that and have done some research into that, building on others. Technical complications, less so. Lack of strong and water-specific targets, definitely, and lack of building control inspection enforcement is a definite barrier to performance. So I think that's just a really, you know, we're quite. It's a very it's a very clear summary on what we think we need to fix, what we need to do. It's probably too concise, but again, we can discuss the ins and outs of what needs to happen in the discussion. So onto the design guidance. Model specification was the key part of it. We wanted to create a model specification fittings-based approach that would really help many of our members, developers, designers cut to the chase, so to speak. There are some notes on the back of that specification. There's a model offset specification as well, that's step 3 of the hierarchy. There's a series of recommendations for developers and their design teams, and then definitions. So into the model specification. I mean, I'll just pause it here. Really, I'm sure you can read this, but essentially we've gone through the fittings-based approach using a Part G, the option 2 table as a basic, and we've consulted with various stakeholders, various developers on where we think the sweet spot is for water reduction. And there's some notes here, so do have a look at it. It's a template that we can use that you know, planners, local authorities, clients, developers, architects, engineers can use in a specification. I think some of the reasoning behind is actually very valuable. You know, why have we gone for these ratings? It is set out in the notes here, so specification notes, and you can read through that. And there may be some disagreement, but I think this is the value of a guide. It's saying why we have decided to set the bath at this size, or the washing machine at this size, or whatever it is. There's further notes on rainwater harvesting here, and some on grey water, water softeners, pipe work and metering. You know, very important thing. Smart metering is really critical to delivery of real performance. And then the model offset specification. So again, this was led by some of the water companies. Shout out to Thames Water here, but others doing the similar things of going into retrofit homes, both installing smart meters, but also looking at retrofit and how they can offset certain amounts of water in their resource zones. And these are the sorts of things that they're doing. And here's a bit more on that model offset specification. So again, how can you go in and this is really the only 2 pages we've got on retrofit, and it probably does need a bit more guidance to go through that. So for houses, it's, I guess, a bit more, it's slight, I don't want to say simple, but it's slightly easier, rainwater harvesting in houses and specifications. We've set that out in this diagram. We've set out some recommendations on how to prepare, brief, and design for water neutrality, or at least up to the stage 2 of that water neutrality framework. The apartments a little bit more tricky, but you know, very viable, very deliverable. It's normally a larger tank. There's the dual pipe system, same as houses. Quite often this can be integrated with water sensitive design as well within the landscape. So that's some of the case studies have shown that. So it's not just water reuse inside the homes, but actually in landscape. And there's that obviously overlap with SUDs and rainwater runoff as well. And then before we get to the case studies, we thought we'd put in the definitions. I think most guides put them either at the front or the back, but we put them in the middle. We think it's such a crucial issue that we just need to agree on some certain definitions of what is what. There's lots of confusions around what is grey water, what's rainwater, what does smart metering mean. So I think that this help clears up some of that. Water offset, dual pipe, lots of these terms that I didn't really understand going into this research, so really useful to bring that out. And then an incentive structure that Thames Water have started, and this is now a requirement for water companies to look at this incentive type approach. So here's Thames Water. I know Anglia and lots of others now have very similar, although not quite as generous, I have noticed, as Thames Water. So maybe that will change. So going in the case studies, we started just on the case studies. We started with a list of about 46 case studies, and we had about 10 international ones on top of that. We whittled them down really by process of sample. It's fairly normal sampling methodology, but we wanted to have a spread of case studies. So we wanted large one, small one, geographic spread as well, although it's noticeable that most of them are in water stressed areas, so East Anglia or Sussex or even out west. We then were going to put some international ones in. We actually wanted to keep them UK based to show how this was being delivered in primarily England. And we wanted to highlight a spread of solutions and really focus on the ones that we thought could be scaled up. So this isn't really a guide for one-off houses, although I think that's very applicable. It's more around the kind of 50 homes plus, or the 20 homes plus at least type developments. And just a note on the case studies and how we've evaluated them. So we've used this performance web. It's called various different things, but essentially it's a metric. We can look at multi-parameter metrics. We highlighted these 7 aspects that we thought were important to development teams and actually housing associations who might then, or build to rent people who might be monitoring and maintaining these systems. And we've evaluated them on these on this basis. So 1, 2, 3, score 1 being a low score and score 3 being a high score. So you can see that each case study is going to have quite a quick way of evaluating, or at least seeing how that and very high level. That's the downside of this, but a way of evaluating how well it's performing across these metrics. A lot of this has come from as-built data. Some we haven't been able to get that as-built data, so we've highlighted that in each case study where we've got monitored data or where it's just design data. So this is the spread of the 6 we went for, 6 case studies. We've got a couple in Cambridge, one in Manchester, one in London, one in Bicester, and again one in London, but a slightly different one in London, a bit larger scale and mainly looking at offsetting in that case study. I think the icons are all self-explanatory. You can see it's steps 1, 2, and 3 of the water neutrality hierarchy. So just to spend a bit of time on some of these, Knights Park, I think it's been really well publicised through lots of areas, and it's won lots of awards. But I think the interesting one on this one is it was an integrated system, so it's rainwater harvesting for both in use in home and external uses. And it's at a scale where, and also land value, where they can really afford to do this and where it's really well needed. So that's probably why it's come through as a case study. And this was built 2 or 3 years ago. It was complete. So yeah, relatively innovative at the time. Second one also in Cambridge. This is called Clay Farm. Other people would have known it by Clay. It's part of the Clay Farm master plan. Again, this is a communal rainwater harvesting system. I think this is one of 2 possibly in the country. I think there's one in the Olympic Park as well. Collecting rainwater from all roofs and then going into communal system that's used for flushing WCs. So this has been monitored. We've got Equality who've done monitoring here, so we're able to see some of the performance, and this is the as-built performance metric. So actually pretty good in terms of its performance, and with and resident feedback as well has been pretty good in terms of their water bills and resilience for water over the summer. Third case study in Salford, so the Z House. Quite a simple approach, really. It's focusing on stage 1 and stage 2, but this is the smart rainwater butt. Smart being that it can connect to the internet, can see when it's going to rain, and it can manage how that water is being used in the garden. Again, that's something that you could be scaled up relatively simply across individual houses. Grey water recycling, so this is an example in Holland Park. Again, we've got some monitored data from this, from SDS, I think in this case. So it's relatively bespoke, quite high level, quite high values in this part of London, but clearly getting a significant saving in terms of that water reduction. The fifth case study, Bicester Ecotown. Again, that's known by lots of different names, but I'm sure everybody knows the big development in Northwest Bicester. This phase, sustainability led by Bioregional, and again using monitored data, so able to show actually it exceeded their design target. And again, it's quite a simple rainwater harvesting system, individual tanks, submersible pumps, and feeding into bathrooms for flushing WC. So just the WC link there. And then finally, the offsetting case study. This is the Royal Exchange in London. And we've got monitored data from Thames Water. And this actually was really fascinating one in terms of the concept of offsetting, and we did look at lots of other case studies that were looking at offsetting in different ways. Some were looking at building reservoirs, some were looking at the wider water resource zone, and how they can offset within different uses, whether it's schools or commercial. This one's looked at water saving, obviously in the same area, and it's looking at retrofitting of the existing homes in the area. There's quite a lot of detail in the back in terms of how that's been done, and Andrew, who's on the call, was very close to this project, so he can provide details if you've got questions for him. So I think I'm drawing up to my time. I think I've probably got another minute. That's the bulk of really what I wanted to share on the call. We do have stakeholder stories, as I said, that I'm not going to go through them now, but really interesting reads, so do have a look at those. And then the appendices, the useful links. It's really relatively high level literature review, but I think some of these are really useful case studies and evidence base. Some of it on cost here, and the environmental incentives I'd definitely recommend you having a look at. I think that's it. So yeah, I think Rich has already said thanks, but here are all the people who've contributed. Thanks to my co-author Rory, Kath Saffron, we've thanked them, and then all the steering group as well. I think it was very collaborative, co-produced piece of work, and we'd love to continue this into the next years. The Good Homes Alliance looking at version 2 possibly, or even what do we do next around integration of both runoff, so water sensitive design, and also water use. That's it. I think I'm going to hand back to Katie for Q&A. Thanks.
Well, thanks, Tom. Thanks. Yeah, I've seen a couple of questions come through in the Q&A function, but we did have quite a few, as I mentioned earlier, we did have quite a few questions come in prior to the session. So I'll run us through a few of those, and then I'll look at the Q&A function live. And then if there's anything that we don't get to because we run out of time, then we'll look to pick them offline. But to start with, we've got there's a couple of questions I think could probably go together. So start off with, what is a reasonable water use target for new homes? And then kind of in addition to that, how do the panel suggest water efficiency targets go beyond beyond what's regulated? So I'll hand that over to Tom to start with, and then maybe Andrew, if you can kind of come in.
Sure. Yeah. So what's a reasonable water use target? This is the question, really, isn't it? And it's being consulted on as we speak. So just before we start, then, when we started this research and the production of the guide, we had quite a long series of debates and meetings about how are we going to do this, and really it challenges that question. It's not really about what the target is. It's actually far more about the mechanisms of how we deliver that, and this has quite a lot of synergy with the energy performance gap and other metrics in new development. It's not really about the theoretical standard. It's far more about the mechanism of how we enforce it through planning, building regulations, and how we ensure the right kit gets delivered. So we saw some evidence, and Andrew can expand on this, around the water calculator not really delivering it, and especially that litres per person per day being quite a problematic metric. So that's why we focused on a fittings-based approach. It's just making sure the right kit, the right specification, both step 1 and step 2 gets delivered, rather than focusing on this litres person per day calculation. Don't know, Andrew, if you want to add to that.
That was a great summary, right? So,
so nothing to add.
It's so easy for everyone to get so focused on a target. It's so easy to try and want a target number or something that's in a document to follow. The problem with the current methodology of using litres per person per day is that target is a mass balance thing. So it incorporates some assumptions around that. There are 4 variables: the volume or flow rate, and then that's coupled with the frequency and duration of usage. These documents are, for instance, Tom mentioned about building regs being consulted right now. That document is aimed at architects and planners and developers. It has next to little to do with anything of the family living there for the next 10, 15, 20 years. And we've been monitoring actual consumption through smart meters of new homes built to these theoretical numbers, and I can tell you right now that the actual real life usage is nowhere near those numbers. So we've provided this information through this document with Good Homes Alliance. We provided it to DEFRA, the Environment Agency. Is it a bit disappointing to still see numbers quoted in a consultation? Yes. Or is the consultation finally the one and be all mechanism to get rid of the wrong metric to include that? So the key, Tom's right, the key thing is that whatever mechanisms or vehicles you've got, it's a building regulation, it's a planning process or a planning requirement, or it's another incentive somewhere else to try and go beyond different things. The key outcome is to get the right kit in that house through those mechanisms. How people use it is the responsibility with a totally different audience longer term. So I think the main thing is, do not get fixated on 125, 105, because we can absolutely categorically tell you that you'll have such a variety of huge range of actual consumption when real people live in that place. The most important thing is these mechanisms here get the right kit in the house that is efficient, and then we can then focus on helping that family use it better for the rest of their time there. And this document, this piece of guidance is a really, really good thing to go on if you want to get that right kit in place.
Well, thank you both. The next question then, a water industry representative said building regulations currently limit water efficient technologies in homes. Is that right? Andrew, are you able to take that one?
Yeah, I'll jump in there. So the current Part G process, and I'll hold my hand up, I'm like a part co-author of a part of Part G many, many years and years ago, and I'm desperate to try and play a role in getting it fixed. So the current regulation or process doesn't really limit it. It just doesn't drive it, nor does it really incentivize it. It does the bare minimum. So it's an evolution of the old Code for Sustainable Homes, which did try and push a lot of boundaries. A lot of negative stuff came off the back of it. It was still using the wrong metrics to do it, but it drove an agenda. The current version is a sort of a dumbed down version of the Code for Sustainable Homes, but it is the bare minimum. It's the absolute bare basics. For the most part, the second version of that did include, you can either A, use a calculation approach, or B, use a fittings approach. The fittings approach is sound and is the evolution of what's gone into this guidance document. And the recommendation is to just drop the calculation methodology, because it absolutely does not guarantee that the right kit will be installed. You can play with it. And it doesn't mean that you'll end up with a house that averages out at this litres per person per day thing. So the current thing doesn't really stop you from doing it, but you've got a problem with customers aren't really asking for it. So there's not a big consumer demand for it driving it. If there was a big demand for it, developers would do it. So they're not getting asked to do it very much. And the current regulation and the planning process doesn't really enable or incentivize them very much. That's why you've now got to try and fill a void until building regs comes on and becomes a stronger stick. You've got now water companies that have got a carrot, which is the environmental incentive. Now that fittings-based approach and the environmental incentive copy-paste has pretty much gone into the model specification that Tom showed you before. That's now in this document.
Great, thank you, Andrew. And I think we've kind of touched upon this, but just to see if there's anything else you want to add to close this out. How can regulations and national policy ensure greater implementation? Experiences that there is little uptake or take up voluntarily. I don't know, Andrew, if you want to take that one.
Yeah, I'll certainly start it. So the building regs is one of the vehicles or one of the mechanisms that needs to play a role. And that's why DEFRA are consulting on it now with MHCLG to strengthen that process. Planning also needs to be a mechanism, because we often talk about how do you get reuse technology, grey water, rainwater, or alternative water sources in there to displace potable water. Building regs might have a role to play. I think DEFRA have certainly made a real effort in trying to clarify the wholesome water issue. So if you haven't read that, please go and have a look at that. And hopefully that opens the doors to go further than just the basics. Planning in other places around the world is often a mechanism. So for instance, building regs might be the minimum standard that has to be applicable to everywhere, but maybe those technologies are not applicable everywhere. So then how does planning come in and say, okay, if you want to build here with that type of building, you need to do this. And building regs becomes the minimum to get the basics anyway behind the scenes. So there are lots of other mechanisms that we need to be looking at in order to try and get this happening. Because otherwise, if we don't, all we're simply doing is adding a future problem to to the water, the supply demand deficit, which is already exists.
Well, thank you, Andrew. I think this one might be for you, Tom. With water scarcity becoming more commonplace with each year, what is the one system or technology that we could use, that we could be including?
Yeah, I mean, that's a good question. I'm not sure I'm going to give you a straight answer, give you a politician's answer. I think step one is the hierarchy. So reduction of use is the key thing. And that's showers, WCs. I think after that, like rainwater has been the one that we've seen shine through most. Rainwater harvesting, that is. There is a downside of that, over prolonged drought. It's not going to last that long. It's pretty obvious. But in terms of cost, carbon benefit, it kind of stacks up above grey water and various other systems. I think from a technology point of view, probably the number one is metering, like smart metering, and getting that feedback to residents and driving that change. And then on that theme, a transparent label, labeling for the fixtures and fittings. So various other countries have this, but if you did have a water label for every water fittings, so showers, taps, WCs, and then also through to your water reuse technologies, that would really drive knowledge and transparency in that.
Thank you. And maybe just to build on that, Tom, although we'll see, maybe just to build on that, what can we do that is both practical, affordable, and cost efficient to save and reduce water usage in the home?
Yeah, I mean, I think it's a similar answer, really, isn't it? I think the most cost effective is the fittings, isn't it? And that we've shown in the guide that can be less than £500 extra, depending on how you do it. Even cheaper if you're going for really minimal savings. There's various types of new technologies coming in the market, but especially looking at the issue of dual flush toilets. But I think smart meters, really, that would be my number one technology. It's practical, it's cost effective, and if you can have a mechanism back to the resident as well, they can see how much they've been using. That's very useful.
Yeah, definitely. So smart metering is going to underpin all of the demand reduction work going forward. It's going to underpin.
Did you want to say a bit more on dual flush, Andrew?
Yeah,
Why we
yeah.
didn't?
So, I mean, we've been working with government, we've been working with industry through the Bathroom Manufacturers Association over many years now, and off the back of our home visits, our water efficiency home visits called a Smarter Home Visit, and also a business version, Smarter Business Visits, qualified plumbers going out there to fix stuff. We've been inside we've done full retrofits and wastage fixes on about 370,000 homes now. In the Thames area, and other water companies have their own versions as well. We've been into about 16,000 businesses doing the same. So installing water-saving devices, fixing internal wastage. And those internal wastage is mostly leaky loos and dripping taps. The leaky loo thing is the biggest part of that wastage thing. So our smart meter data, we've got over 1 million smart meters giving us hourly data. So we know how much is continuous flow. So roughly 8% of all homes in our area never stop flowing. And that of the total water being delivered to households, it's about 7 to 8% of the total water that goes to homes is continuous flow. The biggest chunk of that is leaky loos, and 90-something%, high 90% range of the leaky loo problem is a mechanical valve dual flush toilet, push button toilet. So it's just because you've got lots of moving parts and the failures of the rubber or silicon seals, both the drop valve and the inlet valve, that needs to be engineered out of existence. That we need to get past this technology. There are new products coming to market, and the design spec that's in the document is a great step in that direction. So, average leaky loo, between 250 to 400 liters a day per leaky loo. That doubles an average family's total consumption, just because it never stops flowing through the day. So it's a huge chunk of water across the country that this needs to be engineered out of existence. So smart metering, as all water companies in AMP8 are rolling out AMI, so advanced meter infrastructure now for the next 5-10 years plus, that's going to give hourly data. Hourly data is the sweet spot to find continuous flow, and that means you can find it faster, then therefore you can engage with the customer better and fix it faster. This document here and the other things around building regs and labeling coming in and hopefully stronger standards needs to be the thing that removes that future problem from the market. So it's a twin track approach we need to take to get rid of this problem.
Thanks, Andy. Okay, we're going to move on to some of the live questions in the Q&A function now. So the top one we've got from Claire Weston. What are your views on the need for an as-built check on water efficiency for Part G?
Yeah, I mean, that'd be great, wouldn't it? I think thumbs up for that one. Claire, do you want to add anything to your own question?
Hi, Tom. Just working out how to turn my video on. Not sure if that's working. Yes, I mean, my sort of thoughts were really, we do Part G calculations for developers, and generally speaking, we do those at design stage, and we do a performance specification to meet the target. It's quite rare for us to get asked to actually check that the installed fittings meet that specification. And very often when we do, what we see is that the specs that come through from either the kitchen supplier or the bathroom suppliers don't have flow restrictors on, which we then have to ask them to add. So I think a lot of the time calculations are being done quite early on, and there isn't that sort of follow-up check on compliance. So I think that's it'd be fairly straightforward to implement something there, which would make quite a big difference to make sure we're getting a bit closer to those performance specifications.
Yeah, fundamentally agree with that, and possibly a planning condition as well. We've seen that come through. Someone else asked about what can planning do. I think we've seen happen. LLDC have put it through on a job I've worked for. It's a planning condition. It's also in their design guidance at LLDC, so near the Olympic Park and all that. And then it's been conditioned. So there's a way to go back and check that and see the as-built report. The Code for Sustainable Homes used to do that, didn't it? You have at least had a mechanism for code assessors to go back and check. Or do a site visit. I don't know how much they looked into the detail of the water. Probably not that much.
Yeah, they used to go out and turn the taps on and see if they were or not, but not particularly scientific.
Yeah, I think a building control is the right mechanism for it.
This process will hopefully become easier in time. I know that DEFRA obviously have launched the consultation for Part G yesterday. Great, long time coming, but what we're missing though to make this process much easier is the mandatory water label. Once you have a mandatory water label, in the same way that you've got the A to G energy one, that becomes your mechanism to just replace the stuff that's in building regs and fittings and say we require all new buildings to be A or B rated products only. Done, move on. But it also gives future building control and planning authorities a better mechanism to actually assess if that product is fit and meets the standard. So once that's out there, hopefully, fingers crossed, if there's any DEFRA EA people on the call, please hurry up and get it out there. I know you're working hard on it, but please hurry up and get it out there. That will make this topic a lot easier to get through.
Bill, thank you. Thanks, Claire, for that question. And then we've got one from Charlotte Sangway. To what extent does the consultation on building regs update address recommendations within the guidance? I don't know if that's a premature question, but
I need to spend more time reading yesterday's consultation.
yeah.
Politicians' answer there, even though I'm not one of them, but I know they've had visibility of this document. I know we've given them so much information in the past, but we probably all need to spend a bit of time really reviewing that consultation document to get our heads around how far it goes.
Okay.
Yeah, I think the Good Homes Alliance will be reviewing it and adding our own. So people have got particularly strong views, please let us know. But we'll be responding to that consultation in the next few weeks.
Well, thank you. I think we've got time for a couple more questions. So Greg Scott has asked regarding water efficiencies, have there been any projections and potential solutions regarding the potential negative impacts, for example, wastewater output, more concentrated, higher ratio solids that might manifest on existing infrastructure where new developments will rely on it?
That's a good question. Greg, do you want to come and expand on that if you want? Is it more about the overlap with surface water runoff and sewage, or are you talking more about grey water sewage on treatment on site?
Oh yeah, it's on the foul side. So where most of the kind of the solutions on fittings, they're reducing kind of the clean water inflow that effectively comes out the waste side. So it means that what does come out of houses through the waste into the wastewater system will be more concentrated and have more solids in it. I would imagine in terms of new development infrastructure, there'll be something to do with making sure the flows will be handled better. Because they may need steeper pipes to move those solids, but obviously a lot of new developments will connect into existing sewers, which may be designed with slightly older ideas of what wastewater loads will be like. And if you're going to be making them a lot more concentrated, you're at risk of things like hydrogen sulfide, because there's less sort of clean water and oxygen in there for sewage to deal with, in addition to just like higher levels of solids. I'm not entirely sure what all of the risks of that will be, but I can see there being some. I just wonder if any of that has been thought at this stage.
Greg, it's Andrew. There was it is a topic that has been raised a number of times in the past. I'm not the expert on it, but I believe there was some work done at Acquia or Water UK level some time ago. I say sometime, several years ago. I don't know how in depth it went, but what I heard from it is that the risk was at the time fairly incremental, fairly small. That was identified. However, I've also heard rumblings that the topic has come up again in more recent times. So there might be something that is going on right now at that Acquia type of research level to try and quantify that, particularly with the growing emphasis on demand reduction with national targets and pushing for things such as new homes to play their role, water neutrality to play their role. So I suspect it's a topic that's going to get a little bit more airtime soon.
There's just to add to that as well, there's a couple of projects in the pipeline on enabling water smart communities that are looking at the impacts on the sewer network if we reduce obviously water consumption, water flow. I think the initial modelling and results of that is due in the next couple of months, and then we're looking at an additional project that kind of tests that modelling on real life sites. So kind of keep an eye out for the results of those in the coming months. I think we've still got a little bit of time, so I'm just going to go down to one that's got a couple of likes on it. So this is from an anonymous participant. If the 1991 water legislation was changed to allow Thames to supply and adopt an alternative supply, would they adopt? I think
is this referring to Thames sort of owning like grey water infrastructure or black water infrastructure or something like that?
I don't know.
Dear anonymous person.
Yeah.
I'm just trying to clarify.
I'm wondering if it's around supplying of like reuse water rather than potable water.
Possibly, yeah. It kind of feels like at the moment that's not our area of expertise. We've got so many other normal bigger issues to sort of go for. I know that the new appointed variations, the NAVs, the insets that are now in place and growing quickly. So I know that they are often a mechanism to bring in alternative technologies into that new build area. We're looking at, so from Thames and other water companies, you're typically looking at the much larger scale. So, you know, do we reuse, have a greater reuse from our own effluent and discharge from our own wastewater treatment plants, as opposed to some of the smaller models where you've got newer villages or, you know, new estates being built at that lower level, which, as I said before, is typically where NAVs are playing a role in coming up with options.
Well, thanks, Andy. I think there are certain areas of the UK, because we've mentioned Cambridge earlier, and I think was it Knights Park that you had, Tom, as one of your case studies? I think I know that as Eddington.
Eddington, yeah.
I think the reuse system on that is owned by Cambridge Water, so that would be applicable in that instance. So it is happening and it is popping up. And I think potentially if those regulations were changed, it would become more mainstream as we go on. But yeah, I think
Brido as well. The second one used potable water. If we're talking about those regs,
yeah, okay. All right. I was going to go on to the last question here, but it looks like Mark's helped Claire out on that one. Was there any left in the chat that's I've missed?
I think we're done.
I think that's about it. Yeah. Okay. Brilliant. Thank you everyone for coming and listening and partaking, asking questions, and thanks Tom and Andrew for being, and Richard for being our panelists and speakers today. Much appreciated. And Nathan, I think Nathan's gonna, as long as we've not had any objections, we'll create a series of videos of this so that it can be shared wider. So thanks everyone, and enjoy the rest of your afternoon.
Thanks, Katie. Thanks all.
Thanks all.
Bye.